This screencast contains a little bit of additional hints and help for Module 1, Lesson 1, which is just really getting us into solving equations. So first of all, let's talk about when I use the word terms, what does that mean? So like terms. Like terms in math have the same variables and those variables are raised to the same power. So there's a whole bunch of terms down here that I just wrote and listed, but they're not all alike. So some of them are like terms and some of them are not. So let's take a look. 36 with no variable at all. 3x squared, 2x, 10, 0.5x, 6r, 17rx, 8r, 4r squared, 2x squared. So let's take a look and let's figure out which ones are like terms. And I'm going to color code because I just think that's easiest. 36 with no variable at all. It's just a straight up number. It's a constant. I'm looking through my list. This is a like term. So those two I'm going to put in the same color because they both have the same variable raised to the same power. In this case, they have no variable whatsoever. Okay, let's see if we can find some more pairs. 3x squared. Okay, this is not a like term because it's not x squared, it's just 2x. So 3x squared, we need to look for anything else that has x squared. This is not a like term for this one. Why? Because the variable letter is not the same. They're both raised to the second power, but the variable is not the same. Okay, so it's got to have the same variable raised to the same power. So looking through the list, this one over here is a like term because it's got x raised to the second power. So these two are like terms. I could combine those if I wanted to. 3x squared and 2x squared would give me 5x squared. Okay, let's see. Next I have 2x. So I'm looking through my list. Do I have any other ones with the same variable raised to the same power? This has x raised to the first power, or just x. This one has x raised to the first power, or just x. Okay, so 2x and 0.5x are like terms. So if I wanted to, I could combine those if they were both positive, and that would just be 2.5x once I combined them. All right. 6r, I can't combine it with 17rx because this one has two variables, this one only has one. However, I can combine it with 8r because it's got the same variable raised to the same power. Again, assuming both of these are positive, I could just simply combine them and that would be 14r. 17rx, there's nothing else in this list that's a like term for this one because it's got to have an r and an x. Over here, 4r squared. There's nothing in this list that's a like term because nothing else has r raised to the second power. Okay? So just so you understand what terms are, they can be constants or they can have a number with a variable, and the variable can be raised to a variety of powers. But anyway, those are what I'm talking about when I say terms. In equations, terms are going to be separated by a plus sign, a minus sign, or an equal sign. Okay? And I said this a couple of different times in the two other screencasts, but in order to solve equations, the first thing you need to think about is I've got to get all of my like terms together. I've got to combine like terms. So for instance, I would have to get the just plain numbers together. I would need to get the x squares together. I would need to get the plain old x's together. Okay? If the terms are on the same side of the equal sign, just combine them. Okay? Using whatever sign they already have in front of them. Okay? But if a term has to be moved across the equal sign, then you're going to have to do that by basically doing the opposite. So if it says plus 6r and you need to move it to the opposite side, well, you're going to have to say minus 6r. Okay? So you do the opposite to move it across the equal sign. Across the equal sign, you do the opposite. If you're not having to move it across the equal sign, just put them together. And then whatever you do to one side, you have to do the other. So if you moved something by saying plus 6r, well, you have to make sure you do plus 6r on both sides. Okay? And you just need to make sure that all your like terms are combined before you finally solve to get the final answer for whatever the variable value is. Okay? So just keep that in mind. And then I'm going to use the rest of this screencast to do a couple of problems to kind of help you out. Okay, so I've got a very simple equation right here. It says 12 minus 13f equals 9. All right, so the 12, and by the way, if it doesn't have a sign at all in front of it, we assume it's positive. So I've got a positive 12, it's just a plain old number, and a positive 9 over here. Those two are like terms because they have the same variables, in this case none, raised to the same power. And then I have a term right here that's got an f. Okay, so remembering what I just said, I need to combine the like terms. So I need the 12 and the 9 together on one side of the equal sign so that I can put them together. Okay, and kind of the goal of this ultimately is you want everything on one side of the equal sign and then the stuff with the variable that you're solving for on the other side. So I need to combine these. But in order to do that, the 12 is going to have to hop across the equal sign. And remember from the hints, if you have to move it across the equal sign, you're going to have to do the opposite operation. Remember, if there's no sign at all, we assume that it's positive. So if this says plus 12 right here, doing the opposite is minus 12. And then the other rule is whatever you do to one side, you have to do the same thing to the other side. So you wind up doing this. Okay. You wind up with negative 13f. And then I'm combining these. 9 minus 12 is negative 3. Okay, and then once you've combined everything as thoroughly as you can, then you can take this term and figure out what f is. And this says negative 13 times f. So in order to get f, I'm going to do the opposite. Divided by negative 13. Divided by negative 13. And that's going to give me that f equals a negative 3 divided by a negative 13. So negative over negative, that I can just drop that. 3/13. Okay. All right, now we have another example. I'm going to go ahead and look at my equation again. And remember to always look at the sign in front of your term because that's part of the term. So this is a term negative 5. It's got no variable. Over here, I have a like term, negative 2, because, again, it also has no variable. All right, and then my other terms, negative 2z, here's a like term, negative 4z, and over here I have negative 2z. Okay, so the first thing I'm going to do is I'm going to put these two together. They're on the same side of the equal sign, so I can just combine them. All right, negative 2z and negative 4z is going to give me negative 6z. And then I'm just going to rewrite everything that I still have that I haven't done anything with. And here's what I have. All right. So again, here are my like terms. And now I need to get like terms on the same side of the equal sign. It doesn't matter whether the constants, just the numbers with no variables, whether they wind up on the left or the right. It doesn't matter. But I need to get those on one side of the equal sign and the z terms on the other side. So here's what I'm going to do. If I add 2z over here, remember whatever I do to one side, I have to do the same thing to the other side. That's going to give me negative 4z. Adding 2z on this side gets rid of that. Okay, so I'm making a little progress. Now I need to get the constants to the other side. I need those combined on the other side. So I'm going to add 5, add 5. Remember, do the opposite to move it to the other side of the equal. And whatever you do to one side, you have to do the same thing to the other. So I wind up with negative 4z equals 3. Now I can finally solve for z. Divided by negative 4, divided by negative 4. Z equals negative 3/4. Okay, so hopefully that'll just be a little guidance on how to deal with like terms and putting them together. These two examples are fairly simple, but the rules are always the same. It's just, sometimes the equations can be more complicated. Okay, the last thing I want to touch on with your hints and additional help is kind of the magic decoder for word problem situations. So I'm going to give you a copy of this, but I have found from past experience that some folks struggle to correctly translate what's written in words into a mathematical equation. So any of these words or any of these phrases would mean the addition operation. Any of these phrases means you're subtracting. These types of phrases would indicate multiplication. These type of phrases indicate division. These sorts of words would indicate an equal sign. These sorts of words indicates that things need to be put in parentheses. Okay, so I'm not going to read them all because you can do that. But let's do a few examples together just to kind of get you started. And you will have plenty of practice, maybe on your own without taking a grade or whatever, but you'll need to be able to get these translated properly. So properly. So the product of 7 and b. Product means to multiply. So that's going to be 7 times b, or you can just say 7b. Okay, that's what that set of words means. Okay, the sum of 1/3 of s, so I'm going to have to break that up. 3/4 of x and 4. So the sum of this, this, and this. Okay, so 1/3 of s, and it's a sum, so I'm adding these three things together. The sum of this, 3/4 of x, and 4. Okay? Maybe we'll clean it up and instead of having the slash, we'll do 1/3 s plus 3/4 x plus 4. Okay, so it kind of takes some critical reading to make sure that you're translating these properly. Okay, 1/3 of the sum of 2 and b minus the product of 7 and d. Okay, so they can get quite complicated. Okay, I'm going to give you some of these, and you can just practice kind of on your own. But you'll need to be able to have that skill kind of solidified so that when you start looking at word problems, you know what to do.